11.2 Statistical Studies and Sampling Methods. Jacinta and Felix were each asked to design a study to answer the question, what proportion of students at this school listen to music while studying? So Jacinta chose the following: 1, 2, 3, 4, 5, 6, 7, 8 students, and just asked them these questions. Felix chose to ask looked at the kids listening to music in the library and just checked off how many kids were listening to music. Out of a total of 100 kids in the library, 43 were listening to music. All right, so something to think about. We're kind of going to look and see if there could possibly be a bias due to the way the people were sampled, or maybe how they were observed, or something like that. So these are things to think about to see if these would give us accurate results to our question. Remember, the question is, what proportion of students at this school listen to music while studying? So think about that as we go on. When we choose a type of study, we have three that we're going to look at. A newspaper polls randomly selected residents in a town about which mayoral candidate they prefer. And this is called a sample survey. The sample survey asks every member of the sample the same set of questions and records the answers. So you don't necessarily ask everybody, just a sample. And it's a survey, so the same questions are asked to everybody and the answers are recorded. Here's another type. A doctor conducts a clinical trial of a new blood pressure medicine by prescribing it to half the patients in the study and measuring the effect it has on their blood pressure. This would be called an experiment or an experimental study. An experiment involves applying a treatment to some group or groups and measuring the effects of the treatment. And we're going to talk about this a little later too, where we have a control group and an experimental group. And that's important when you're doing this kind of study. Here's another way we could research information. A grocery store wonders how many customers bring reusable bags to the store. They have an employee stand at the checkout and count the number of bags by using reusable bag, the number of people using reusable bags. So this would be an observational study. In an observational study, you measure or observe members of a sample in such a way that they are not affected by the study. So life is going on all around, and someone is just observing what is happening, and they're using the data that they collect to possibly make some conclusions. So of these three that we talked about here, in which type of study might a person be unaware that he or she is a participant? Well, I would hope, if the sample survey is obvious, and I would hope that in the experimental survey you knew you were in the experiment. But the observational study, that could be done without the participants even knowing they're in it. This is something to think about. So here's our three types of studies that we're doing. Which type could you use to answer the following questions? Does urban population have an effect on rates of asthma? Think about that for a little bit. We could use an observational study and observe residents of urban and non-urban areas and compare the rates of asthma over a long period of time. This is something we could do. Here's another situation. How many students in a school would like the cafeteria to serve breakfast? What might you do to gather data to answer that question? Seems like you're going to have to talk to somebody, right? If you want an opinion. So probably you're going to need the sample survey. Ask randomly chosen students in the school their opinion. Oh, their option. Sorry, that should say option. And record the results. Here's another situation. A group of plants is not growing well compared to the rest. What should you change to improve their growth? So this one, you can kind of see it would ask for an experiment, right? And you would split the plants into randomly into groups, give each group different conditions. One could have more light, more water, and one could have more fertilizer, whatever. And this should say one. You leave one group under the current conditions to see if the new treatments show improvement. Here's something for you to try. Here's 3 different situations. It has to do with the gym. And you decide which kind of study each of these would be. Go ahead and try it. And when you come back, I'll have them matched up for you. Anytime you see the word ask, you know you're asking a question. It's probably taking a survey. And here they're setting up something and trying something different to see if it's going to build muscle faster. So that's an experiment. And here we're just counting customers that come in before 8 a.m. So we're just observing some things here. And we could use the results of this data collection. We could use the results to make some decisions about our gym. Here's another thing that happens when we collect data or set up our samples. We could have sources of quote unquote bias. And here's an example. We're going to look at this situation to see if there are differences between groups that could potentially cause a bias. A psychologist is conducting surveys to study the happiness levels of people who live in a neighborhood. She asks the same questions to 2 samples below, well, it's to the right here, chosen from the population of the neighborhood. So she did some random samples, but look at the first one. The first one, she sampled 100 people. She surveyed 100 people, and it was a sunny Saturday afternoon. 65% of the people said they were happy. Then she went out again. 100 people were surveyed on a Monday morning, and only 35% were happy. So the difference between the results of these surveys, it's due to what we call bias. Because the circumstances when the 2 samples were surveyed could influence their response. I would tend to be happier on a sunny Saturday afternoon than maybe on a Monday morning when I'm getting ready for work. So the biases can arise for different reasons. It could include a certain category of the population. A poll on a website is more likely to select frequent internet users than those who do not go online often. So that would be biased. Bias can also be introduced in other ways. For example, a survey might have questions that influence the answer in some way. So it's the way you ask the question. Let's look at some more. Oh, by the way, so personal bias, which we all have, we try to be aware of that, or a personal inclination for or against something. And statistical bias are different. While personal bias can lead to statistical bias has many other possible causes. So let's look at these situations and let's look and see if the difference between the groups is due to bias. A school wants to know the average height of its students. The school randomly chooses some students and measures their height. Some students are under 5 feet tall and some are over 6 foot 5 inches tall. What do you think? The fact that some of the data collected are either very high or very low is not necessarily the result of bias. A population like students in a high school will naturally have people with a wide variety of heights. A true random sample may have members from both extremes. So this isn't necessarily due to bias. As you go along, why should you determine whether any differences in the collected data are due to a biased study, or from natural variability in a population? And I wish I'd move that up there. I wish I could. Whoops. The natural variability is one thing that happens, and kind of when you're looking at people's heights, that would be a natural variability. The bias study, maybe you only chose seniors or freshmen, something like that. So that would throw some bias into the data. Look at this one. So a soft drink company calls 500 people at random and asks, "Isn't it true that our product is much better than our rival's product?" And 75% of the people said yes. Is this an example of bias? Explain. Well, probably don't have to think too hard on this one, right? Of course, this is bias, but just because the way the question is asked, this would lead many respondents to give the answer the company wants. Most people would, isn't it true? Most people would probably say, sure. Let's look at these three different situations here, and we're going to decide if the variations are due to bias or variability, the results. So the student council surveys every fifth student walking down the hallway with the following question. So every fifth student, and they ask the question, do you agree that the school would be more enjoyable if we had the opportunity to eat lunch outside? What do you think? Because of the way the question is asked, this would be very biased. It causes the participants to lean toward the yes answer. So we would have to change that question. Every fifth student is a good way to sample, but there will be some bias in it because of the way the question is asked. The second one, Stacy sat in a parking lot between a fast food restaurant and a local diner to determine which type of food most people in her town preferred. Think about that situation. This would have variability, but due to the different turnaround times in each restaurant, there could be bias based on the time. So it's not always black and white as to whether this is biased or not biased. We don't always know right off. We kind of have to look at the big picture. The last situation, a researcher company calls 1 million residents of the United States who are randomly selected from rural and urban areas of each state to collect their opinion of two new federal laws that are being proposed by Congress. So 1 million residents of the U.S. are called. They're randomly selected from different areas, and they're getting the opinion of two new federal laws. There is variability, which is a good thing, although the caller could hang up, correct? And we don't know how they ask the questions either, so that could cause bias that way. So think about these sampling methods that we have here. In order to select a sample that is likely to be representative of the population, remember, sample is just a subset of the population, you need to choose members of the sample using randomness. The simplest way to use randomness is with a simple random sample. In a simple random sample, another vocabulary word for you, each member of the population is equally likely to be chosen, and each possible sample of the size you want is equally likely to be chosen. So sampling methods can involve randomness and other ways to select a sample. Some sampling methods do not use enough randomness to give reliable results. So we're going to look at these 5 methods here, and I love the pictures down here. It kind of gives us a bigger picture of what's going on. We want to be always careful when we pick our sample method to avoid bias. Stratified sampling is when a population is divided into groups with similar characteristics and a sample is randomly chosen from each group. So it might be, ninth graders and 12th graders like we were talking about before. And then based on that population, you're going to pick, based on the number of students in each group, you're going to pick some random people from that group. And notice since these have the same number in them, they pick 3 here and 3 here. And notice, we'll say the blue ones are the ones they chose. They randomly chose those. Cluster sampling is when a population is divided into convenient clusters and entire clusters are chosen at random as the sample. So maybe you have a choir with soprano, alto, and bass. Sorry, tenors. And you were asking some questions from the choir, but you chose only the bass section, but you chose everybody in the bass section. Systematic sampling is when you start with one member, chosen at random, then you use a rule, such as every 3rd member of the population, to select members of the sample. That's kind of like they did before, every 5th person that walks through the door or something like that. So here they chose every 3rd. Maybe these are students coming to a certain class. So every 3rd student, the blue one was chosen, and maybe they were asked certain questions, some survey of some sort. Now these 2 over here have a high risk of bias, so we want to be careful with those. Convenience sampling, it's when you choose, you only choose subjects that are in close proximity or easy to get to. So I'm in a class, and maybe myself as the teacher, I just ask the people in the front row questions because the people in the back row are too far away, so I just don't want to ask them the question. I'm going to get some bias, very likely, depending on the people in the front row, right? Here's another one. Self-selected sampling is using a sample made up of volunteers. So again, the teacher, I might send out a survey, and whoever happens to answer that survey. I don't require it. If it's not from everybody, it might be only those who happen to answer it. So in this particular case, there were 5 that chose to be a part of that survey that I put out. Let's see if we can identify a sampling method. Stratified, cluster, systematic, convenience, and self-selected. We're starting with a randomly chosen ID number, and every 5th student, so think about that, was chosen and then was asked to fill out a survey. This would be systematic sampling. The rule is that every 5th number was chosen, and it is likely to be unlikely to be biased. Here we've got a retailer put feedback cards at the front of the store. They got responses from 22% of their customers. This would be self-selected, the ones that volunteered to do it, which only includes people who decide to respond. This method is not random and likely biased. And something to think about is, could you redesign the study so that their samples are not biased? Maybe you could actually ask every 10th person walking out of the store some of the questions that you're wanting to know. Here's a city wants to know what % of people in the city own a dog or a cat. A city worker goes door to door in the neighborhood around City Hall and asks people about their pets. Well, this is definitely convenience sampling. right? I'm only going to go to the neighborhood around City Hall. That's not very representative of the entire city. Again, how could you redesign this? Think about ways that you could make it less biased. So now you try it. We're going to do the same thing. Which of these sampling methods do you think was used here? Would be a good one to use. The population is grouped according to age, and a random sample is chosen from each group. What type of sampling is that? Stratified sampling. Okay. Do you remember the stratified one? Um, so you have people grouped, but you sample from each group the percentage wise. So this is a stratified sample. It's unbiased as long as the samples chosen reflect each group reflect the age group's percentage of the population and are otherwise random. Let's look at this one. A number of hospitals around the country were randomly chosen. Within each hospital, all the nurses were chosen. And for whatever reason, we're going to collect data on that. So what happened here? So this is called cluster sampling. Each hospital in the country is a cluster, and some hospital clusters were chosen to be part of the sample. It is unbiased as long as the hospitals were truly chosen at random. So they didn't just sample from each hospital, they sampled they took the whole hospital, in this case nurses, and that was their sample group from that hospital. What sampling method is used here? There are 5 elementary schools in the district. Jacob visited each school and asked the grade 1 class at each school what his or her favorite lunch item was. This is definitely convenient sampling because only one class in the school was asked. It's likely to be biased. Different grades may prefer different foods on the lunch menu. You know that. John wants to know what reward students would like the best, movie or popcorn or outside drink, time and a drink. He looks at his attendance sheet and polls every 4th student. What sampling method is used here? Is it likely to be biased? This is systematic sampling. The rule is that every 4th number was chosen. The method is unlikely to be biased. And last but not least, we're going to look how to make sure we randomize experiments. So describe a design for a controlled experiment to test a new drug for treating the flu on mice. How does randomization apply to your design? In a simple controlled experiment, randomly assign mice to 1 or 2 groups. One group we could call the experimental group, and they would receive the treatment. The other group, we call that the control group, more vocabulary, does not. Then we could use the statistics to compare the effect of the treatment to the effect of no treatment. Mice are randomly assigned to either group. All mice are infected with the flu. The control group does not receive the drug. The experimental group receives the new drug. The results are analyzed to see whether the new drug affects the progression of flu in a way that is significantly different from receiving no treatment. The random assignment to experimental and control groups should ensure that the difference between the 2 groups is due to the drug rather than some other cause. And as scientists do this all the time. This is a really, really important part about it, experiments. Now, here's just a side note. Some experiments can have more than 2 groups, especially if you're testing multiple variables, kind of like we did with the plants earlier on. Some experiments don't have a control group at all, and we're just comparing 2 different treatments. So try it. How would design an experiment to test whether drinking coffee improves memory? How would you choose the experimental and control groups? Well, this was my suggestion. The control group gets no coffee. The experimental group gets coffee. And I would give everyone a memory test and compare the results. This is a summary of all the things that we've talked about. So this would be good to have in your notes. Notice up here we have some more vocabulary, right? The 3 different types of studies. And then here we had the sampling methods. So you want to make sure you understand these. It's always good to write the vocabulary out, the definition, and then some kind of example to help you remember that particular word.